Hey everyone, I'm Asher Goldberg. I am a engineering manager at Iterable. My team is responsible for all things related to queuing at Iterable. We'll get into a little later what Iterable is, what we do, why we use queues. But we've been using Pulsar for about 4 years now, maybe a little longer, and it's become the kind of default center of all data that moves throughout Iterable between our services and environments. Okay, so just a quick overview. What is Iterable? Iterable is a SaaS marketing platform. Think of it as sort of a customer lifecycle management platform, not just a CRM, but more of the entire like customer lifecycle management. All the communication back and forth with the customers from our customers, all the data that we ingest and store on behalf of our customers, is all put together and lets our customers work with their customers, to both, expand their marketing capabilities, but also keep their users engaged with their companies and everything that they're doing. So let's see how we do it. Next slide, please. Okay, so Iterable operates across many, many use cases. These are just a few examples in the different verticals of the companies that are Iterable customers. We obviously aren't going to read each logo out loud, but just to give you some idea that there isn't really like a single specific area or even size of company that Iterable is in. We have very small companies that send a few thousand messages a week to enormous enterprise customers that send hundreds of millions of messages a week, and it very much scales accordingly for them depending on their each individual's brand and their needs. Next slide, please. The way that Iterable works, sort of our like kind of Iterable data pipeline secret sauce, if you want to call it that, is we take data from basically anywhere. So our customers, their customers, provide data to us through various APIs and ingestion and queuing and Kafka streaming and all that sort of stuff. We take that data, it all comes into a lot of different Pulsar topics and queues and namespaces and tenants, which we'll get to in a second. But everything in our company is run through Pulsar at least once. Most of them go through Pulsar multiple different times. Data comes in, communications go out, webhooks go out a different queue, tracks for all those events go somewhere else. And all of that data is running through Pulsar, to the order of something like, 50 billion or so messages a day. And each different medium along the bottom here, so email, SMS, WhatsApp, embedded messaging, all of those are different platforms that we support for our customers. To Pulsar, they're relatively the same, which is a cool thing with Pulsar. We don't have to really treat anything differently in terms of like an email versus a WhatsApp message versus any other type of send that we're doing. It's just different queues with different names with different consumers. And everything works, very, very easily. And the barrier to entry for new use cases is, quite low at this point for our other engineering teams. So next slide, please. We're going to talk on the next couple slides about how Iterable divides workloads, or what we call workloads. So I just wanted to quickly explain, like, when we're using the term workload, like what we're talking about, and why Iterable is very unique in its Pulsar usage. So a workload is a distinct product usage by a single Iterable customer. This is obviously not an exhaustive list. This is only a few examples of what could be a workload. But something like a scheduled email that reminds users about an upcoming concert. And the important word there is scheduled, because we're very big users of, delayed and delayed delivery tracking and messages that are going to be sent, at some later date in the future. A series of messages that every user receives on making a purchase. So if you buy something from one of our customers, a lot of times that, order confirmation email that you get is actually coming from Iterable. You wouldn't know it because obviously we don't put our name on it. It's the customer's, email. But that data is of what you purchased and how you purchased and what was in your cart and what you took out of your cart. All of that is being sent to Iterable. And then that transactional send at the end, like, hey, thanks for your order, is coming through a Pulsar queue. And we prioritize, certain types of messages like transactional messages like order confirmations or password resets over like, here's a monthly newsletter that, can go out over the course of a few hours versus needing to be sent, right now. Um, The other two, just other examples of, sends that we're doing. But the important part here is that Iterable has many different workloads, each of which has their own requirements. It could be a SLA for the time that the email has to be arrive by. It could just be the frequency in which these queues are getting, new messages and how our consumers are all working together. But just keep workloads in mind as we go through the next couple slides about how we use all this together in practice. Next one, please. Okay, so these were iterables. These are iterables kind of core principles for queuing. And these came into play when we were selecting a new queuing platform, which was Pulsar. We've been using Pulsar now for I think about 5 years we started migrating from RabbitMQ into Pulsar, and for about 3 years now we've been exclusively on Pulsar. So there was definitely a time period where some of our stuff was in one system, some of the stuff was in another. But for the last 3 years or so, we've been exclusively on Pulsar. Our three kind of core principles are that the platform has to be scalable, flexible, and fair. And all of these kind of come into play with the different ways in which our customers use Iterable. So it has to be scalable. It has to support hundreds of thousands of workloads running in parallel. So we had that previous slide with the example of a single workload. We're doing that hundreds of thousands of times all the time, basically, because every customer is slightly different, and we don't have customers overlapping on the same topics, which goes to the fair column, which we'll get to in a second. Um, Pulsar also can adapt to rapid changes in scale. You'll see in the next couple slides, Iterable's volume is not constant. Emails are sent, there's a heavy emphasis on emails being sent at like the top of the hour on a daily basis. But then also there's, large events like Black Friday, Cyber Monday, the lead up to Christmas, the US election cycles. All of these contribute to huge spikes in volume. And we don't really have to worry about it from my team's standpoint because Pulsar can just easily adapt to that additional scale and handle the load. Um, Under flexible for different new use cases. So we're constantly adding new things into Pulsar, and there's no work that we really have to do to get Pulsar to support that new use case. Everything is just kind of built in out of the box that we need. One of the major like items that we were looking for when we selected a new platform was a first-class support for delayed message delivery. We are very heavy users of delayed message delivery. We have messages that can be scheduled up to 60 days in advance. And so if you're a marketer on our team and you put in, hey, 60 days out, like you need to know that that message is going to get sent exactly when you said it was going to get sent. Um, and then on the flip side, at the individual message level, even we have like a AI driven feature that we call send time optimization that basically takes into account for every user that we have, when's the best time to send them an email. And it could be as simple as that user's in a different time zone and we don't want to send them an email at 2 in the morning. But it could also be because we're tracking the email opens. We know that these users tend to open their emails, at 5 p.m. and later versus at 10 a.m. But for our marketers, that's very annoying to schedule different tiers of campaigns with different times. So if they enable send time optimization and they're sending to 100 million, messages, Pulsar will track an individual different delayed stamp for every single message in that campaign. And they can all be mixed together, all in a different order. They don't have to be ordered. Our consumers does not make a difference. And Pulsar will deliver those messages to the consumers exactly when they hit the time that they're supposed to be sent. So that's like large campaign level, but also individual message level. And then finally, for fairness, we have a very heavy emphasis on customer isolation, not just so much from a security standpoint, which is obviously important with the amount of data that we're handling, but more for the fact that all of our customers are different sizes. And even though we have customers that are, like we said, enterprise level customers versus some of our small ones, we still want to maintain the same quality of service for our smaller customers as we do for the big ones. And that means we always have to dedicate a certain amount of resources to every single customer. And we do that through individual Pulsar namespaces and topics for each customer. So rather than have a gigantic queue for all outbound emails that need to be sent with many partitions, we instead have individual namespaces for each customer. and then individual topics for each campaign. And this is ensuring that we always are giving, adequate resourcing to everything that is happening at the same time. So those are our three kind of core principles. You'll see how that plays in the next couple slides. So let's next one, please. So this is, basically why we ended up choosing Pulsar. Reason number one is its scalability, like we said, millions of topics, producers, and consumers. On a normal day, these are about our statistics for a normal day for us now. Our peak publish rate on a normal day, that's messages per second, is a little over 1 million messages per second, or about 1.25 million messages per second. But again, our volume is very spiky throughout the day, so we're not getting that constantly. But our total messages a day through all of our clusters, we have 8 across our different environments. Through all of our clusters is about 50 billion messages a day. That's a mix of internal event tracking, system events, customer lifecycle events, outbound sends, like we were talking about, all that sort of stuff. Outbound sends typically is only about 1 billion messages a day for outbound sends. So the other, 49 billion is mostly how customers move through our system and events that we ingest on behalf of our customers. On a normal day, we have about 100,000 active topics, about 500,000 producers for various use cases, and then about around 2 million consumers. And again, our consumers are designed in such a way that they're subscribing to a single workload, a group of workloads, many workloads, but they're all a little bit different depending on the specific use case and how we want to enforce, certain customer priorities. Like we said, first class support for delayed messages, multiple consumption models. We typically, for the most part, only use shared consumers, but having those other models and modes for the consumers is obviously very helpful for certain cases. And then the last one is built-in DLQ capabilities, especially for us on our outbound sends. So for us, we use a lot of ESP and sending providers, Twilio, Telenex, those sorts of providers. If they have an outbound outage from us, obviously we don't want our outbound sends to be lost forever. We would prefer that they go through on the first try, but we all know that's not necessarily always possible. So Pulsar's built-in DLQ will sideline those messages that were failed to be sent for whatever reason, and then our engineering teams can take a look through the DLQ and decide, if they want to redrive the messages, how they want to redrive the messages, and all of that's being handled automatically. And then the last part, similar to DLQ, is how we enable topic level retention for these topics. All of our topics have a retention policy on for some for 3 hours, some for as much as 24 hours, and it just gives us the flexibility to rewind that topic and replay the messages very easily if there's ever some sort of outage or issue with one of our providers. Okay, next one, please. So this is how we were saying about our burst in traffic. That top graph shows our kind of daily spikes in traffic. So, you can see, like, obviously it's on the left, to the left of the graph, but around 9 a.m., there was a larger spike. And then throughout the middle of the hour, it gets a little lower. Up at 9:30, it spikes up again. Same, smaller spike, but same thing kind of happens around 10 o'clock. And this is mostly a function of how our customers are scheduling their messages, scheduling their campaigns. We typically target top of the hour just because it's a nice round number to send your messages out at. And Pulsar has to be able to handle that increase, at the top of each hour. In addition to the daily spikes, the graph at the bottom is showing the Pulsar rate in for a period of a few months between September and January this past year, just to sort of illustrate like the volume that comes in per topic or in total gets significantly higher throughout like the holiday season, starting around like early November, middle of November, leading up to Black Friday, and kind of continuing through Christmas. A lot of our customers are in that space where they are, they're selling things, and that's a very high volume time for them, and therefore a very high volume time for us. And Pulsar is flexible enough that, like Laurie was saying, just adding additional brokers or additional bookies is generally all we need to accommodate that load, and it's very easy. As soon as the new brokers or bookies come up, they immediately start either serving traffic or storing data, and there's nothing else we have to do other than, add additional nodes to the cluster. When we're done in January with With some of this peak heavy load, we can easily remove brokers. They're stateless. There's no problem with removing a broker from the list of brokers. Bookies require slightly more time. They have to run through a decommission process on Bookkeeper, but still, it's very easy to remove that extra scale that we've put in for a few times a year. Okay, next slide, please. So this is just a brief overview on our topic architecture and why Pulsar works so well for us. We have different types of topics. So in this case, it's transactional topics and bulk topics. Transactional topics are like, here's your order or here's your password reset. Bulk is like, here are our, specials for the month or something along those lines. We will prioritize different types of work for different types of customers depending on either what they want or what we need to do to protect our system, to ensure that no single customer is sending too many messages or something like that. So for example, on like where it says like org1 consumer and org2 consumer, imagine those as like outbound email providers, and org1 and org2 have different rate limits for themselves. And we need to keep track for ourselves that they only want us to send 250 messages a second or 100 messages a second. So we're tracking per customer rate limits. And the way we are able to enforce that is with our topic structure. Without separating the different topics, we would never be able to do that, because you wouldn't know how many messages are coming until you actually got them. So by separating the topics at the beginning, we can then enforce these rate limits and provide our customers with the level of service they want. We also only use regex-based consumers at Iterable, even if we're subscribing to one topic, just to give us the added flexibility. So for example, this transactional consumer can subscribe to any topic with the word transactional in it. And that makes it a lot easier. The org1 consumer can subscribe to any topic with org1 in it. And that also makes things a little bit easier. And all of our subscriptions are shared, and you can have multiple subscriptions for each topic, for different use cases. So for example, our email topics, our outbound sends have subscription to actually send the email, but also another subscription for the internal event tracking that we use around the email being sent at all. And both of those subscriptions are running at the same time on different consumers with no added pressure on the topic. Pulsar makes no difference how many subscriptions there. I mean, maybe at 100, but certainly not at one versus a few subscriptions does not make a difference for us. And we're able to have that flexibility for however we want to structure our topics. Um, we also are able to apply, different types of back pressure and rate limiting depending on what our customers have asked for us. So either we can't go fast enough or they want us to go faster. And either way, we're able to have that flexibility with Pulsar. All right, next slide, please. And then finally, this is the advantages to us using Pulsar. The lower cost of scaling for us has been basically allowed the company to scale in this way. When we were on RabbitMQ previously, we had far less traffic, um, and we were spending a lot more back then, 4 years ago, 5 years ago, than we do with Pulsar today. And that was with a lot less customers and a lot less different use cases running through Pulsar. Um, Pulsar's advanced feature set, some of which Laurie was, discussing in his slides, give us much more valuable and reliability for the money. We were really struggling with RabbitMQ before with the with the lack of high availability, issues with delayed delivery messages, just the way that the nodes could never really replicate to each other because of our sheer volume, and all of those problems, go away with Pulsar's feature set. We don't cover it here, but we're also heavy users of Pulsar connectors, some of which are open source, some of which are Stream Native proprietary connectors. But we offload messages to S3, we ingest stuff from SQS, we have some Pulsar syncs that send our data directly to Snowflake for some of our analytics teams. All of that feature set, is basically capable with the core Pulsar, infrastructure, and it allows us this additional added flexibility that we never had previously. That's on the financial cost of the company, but there's obviously a whole nother section of this, which is the engineering time and the engineering cost to the company. We no longer have to spend, months onboarding a new use case. Our team, my team writes pretty much like standard queuing libraries that every other team uses. And all they have to do is just hook up their service to Pulsar. Um, we've made it considerably easier to get started. Pulsar's scalability, it allows us to not have to worry about it. So unless a new use case is coming on with, I don't know, 200,000 messages a second of volume, we will not even notice the increase. So our engineering teams could add an additional 50,000 messages per second, 100,000 messages per second, and Pulsar could handle that at our current scale without any real issue. Um, we also don't have to be worried about the company growth being limited by the queuing system. So we don't have to work. Product can, invent and sell whatever features they want to our customers. And we know that all that feature work will eventually run back through Pulsar in some way or another, but there's no longer a need to worry that we can't keep up with what product is selling, which is a very different paradigm than it was here a few years ago, and really has allowed us to unlock a ton of new features and revenue, with Pulsar kind of at its center. Um, and then finally, that last one, we don't have to worry about rapid changes in customer usage impacting our platform. So if our customers are typically sending 1,000 messages a day and all of a sudden they go up to 100,000 messages a day, we'll see the increase. But the way we structure our consumers, the way we implement rate limiting and back pressure, it's not like we'll get all 100,000 messages at 1 second. And it's not like it will immediately overwhelm our platform or anything like that. So, all of these things together, it's been a really great road for us to start using Pulsar, to start working on some of the more advanced Pulsar features. We have certainly grown a lot since we started using it. And I would like to say that most of our growth has really been possible by the features that Pulsar has unlocked for our company and the way in which we're able to service our customers in a way they're expecting, maintain our very low SLAs for our customers, and keep the performance where everyone is happy.